Okay, coming to question 53, this is a rather tricky question, but a little bit difficult to understand. What we're given with is a set S which has n elements, n greater than or equal to 1, and the bunch of subsets of S. Let's consider AI and I being 1 to m. That is, we are considering m subsets of S. Now, all these subsets will follow a property. That property is, consider any two elements of S, let's say x and y, which belong to S, such that x and y are not equal. Then, these subsets are such that you can always find one particular subset which is indexed, let's say, with I, that is, there would exist I belonging to the 1 to m, such that it contains one but not the other. That is, if it contains x, then it does not contain y, or if it contains y, then it does not contain x. That is, consider any two elements of the set, you should be able to find at least one subset from a bunch of subsets, such that it contains one element and it does not contain the other. This is how we are defining all these subsets, n such subsets. Given that these subsets and the set follow this property, what will be the relationship between n and m? That is the question. Now, to be able to answer this question, we need to understand a particular principle called pigeonhole principle. This is a rather basic principle from theory of logic, that is called pigeonhole principle. What does this mean? Let's suppose one has n number of pigeons and you have a certain number of pigeonholes. It is intuitively apparent that if the number of pigeonholes are less than the number of pigeons that one has, then at least one pigeonhole will hold two pigeons. For example, let's say there are 4 pigeons and there are only 2 pigeonholes. Now, at least one of the 2 pigeonholes will hold at least 2 pigeons. What you can do here is either put all the 4 pigeons in one pigeonhole, or you can distribute it in the form of 1, 3 or 2, 2. So, you can see that at least one pigeonhole has more than one pigeon. Now that we have understood what the pigeonhole principle means, let's come back to the question. Now, let's define a set which contains all these AI. That is, let's say S prime is equal to A1 through AM. Now, let's define script S, which is the superset of this set. Power set of this set, which will basically contain all subsets of this set. That is, it will contain a set containing just A1 or A1, A2 or A1 through AM and so on. Now, consider any element of S will be a bunch of subsets of S. Okay. Now, considering any index I, any element I of set S. Consider any random element I of S, then there will be at least one element belonging to this set, that is script S, which contains all the subsets AI which hold that element, to which that element belongs. That is, let me explain that again. Suppose we consider some element x belonging to S, that is the given set. Now, there will be one element of this set which is itself a set of subsets. Those subsets will be the ones which contain x, and rest of them will not contain x. Now that we have understood that, the script S, the cardinality of that will be 2 raised to m. The cardinality meaning the number of sets the number of elements of this set will be 2 raised to m. And if we have n elements in S, and if we have n greater than 2m, then there will exist another element y belonging to S on account of the pigeonhole principle, such that any subset which contains X also contains that y. As I explained during the pigeonhole principle, that there will exist at least one pigeonhole which contains more than one pigeon. In the same manner, there will exist at least one element of S, which is a set of subsets, which will hold X and Y always. Therefore, we will not be able to find any index I such that for any two elements X, Y belonging to S, there exists some I such that one belongs to the set AI and other doesn't. Therefore, that we cannot have S is greater than 2m. All that we can have is n less than or equal to 2 raised to m, and that is the answer.